So before I kickstart the session, I just wanted to introduce myself, guys. My name is RM. I have more than 14 years of industry experience. I head one of the analytics division at one of the prime company. Now you always, they have the name extreme point and the lower extreme point, higher extreme point and the lower extreme point. Do remember that, correct? So now, very simple to understand. This is maximum value, that is called as high extreme point, and this is the lower minimum value, which is called minimum extreme point. That is the between any data between that I will be considering for my analysis purpose. Anything above that I'll be calling that as an outlier and I'll be discarding that value, correct? Now if you do that, how to identify that? So most of you got this right. So we calculate interquartile range. Now interquartile range is basically the difference between 75th percentile point minus 25th percentile point. It's not 75%, it's not 25%, guys, it's percentile. There's a humongous difference between percentage and percentile. So percentile is calculated if I sort the data from descending to ascending. If there are 100 data points, which is the data point which is at the 75th rank? Means from the top it is 25th rank, correct? If I sort descending, and which is the 75th rank, in that means that is the 25th from the bottom, that is the rank. Okay, so I will exactly select those data points. Got it? Now from these two data points I will subtract the value, and whatever the value comes, that becomes my IQR. Now I want to go to the maximum point. Now maximum point is always calculated as 75th percentile plus 1.5 times of IQR. Okay, visualize, guys, how far this is. How far A is away from B is only 1.5 times IQR. Remember like that. Okay, and how far point lower extreme point from D is 1.5 times. So D minus 1.5 times IQR. Okay, right off. This is very important concept, guys. Most of the interviews happen around outlier treatment and the missing value treatment, and that's why I'm paying more attention towards that, because I don't want any one of my students when they go to the interview and they don't answer this. Now let me go ahead and talk about the if statements and or statements usage. I'll say data point as 1 point. I'll just name 1, 2, 3, 4, 5. Let's plot the 10 data points. Okay, these are the 10 data points I have, and this is my value if I try to plot as a variable. So here I have 10, I have 20, I have 30, I have 40, 50, 60, 70, 80, 90, and I have 1000, or let's suppose 250, not that high. Okay, now if I try to plot this graph, just pay attention, guys. What has happened, guys? I'll simply remove this. This is what my line graph is. Can you see this? If you try to fit any of the model, what will happen? And now if I go and try to fit a regression line on that of that, add a trend line, how the trend line will look like? This is far-fetched. Do you see the errors in these data points, and the errors as I go ahead, it will increase. Now if I simply remove that data point, if I discard that as a data point, can you see the impact on the trend line? So in your machine learning model, when you build that, if your outlier treatment is not done, your model will be biased towards that data point. And when you predict any model to learn, it should be extremely closer to the line of value what you have. If you add Control Z, you see the impact of that on the line. And now another thing you would see, it's now outlier is not always on the higher side. Outlier can be on the lower side also. I'll just change that. I'll just make this as to minus 100 or minus 50. Did you see the error is increasing now? Correct. Now as soon as I delete this value and I delete this value, my curve, my line fits exactly to the line.
Yes,
Correct.
sir.
And that's why outlier treatments plays most important role. Sanjay, does that answer your question? So there is no percentile or no percentage rule. Even
Yes,
if
sir.
single data point in your data exists as an outlier, delete that data point. No data treatment. Correct. If your number of data points are less for the model building part, so some of the guys, they might ask you to cap at the maximum point, which is A. Okay. If they don't want to delete that data, so that might be another way to preserve your information. But usually the best industry practice is to delete that information. Don't keep that information. Okay, fair enough. Point clear, guys. So 10% funda is applicable only for missing value treatment. Less than 10%, we will treat and will replace that values. Anything about 10% or 15%, we will discard those values. We'll delete those entries from the data point. Okay. And for outlier, even if a single data point is outside the minimum and the maximum point we identified, we will be discarding that data point. Okay, you want me 4 and 5 data points as an example? Okay, let's do that. I'll build an outlier treatment here itself. Assume I have data points. I'll take more data points for your understanding purpose. Okay, I have taken 25 data points. Fair enough, guys. And I'll use the rand between function. Rand between a minimum value is 0 and maximum value is 1000. Okay, so now these are the values we got it. Okay, now can somebody tell me any 3-4 values that you want to change completely, or instead of 0 let me make it 200. Okay, fair enough. Okay, now give me any 5 random values. Any 5 random values will do. Okay, okay, let's assume this data point is around 60. This data point is around 1300. Let's assume this data point is around 1600. This data point is around 1. This data point is around 10. Okay, now let's identify the outlier, whether data is outlier in this or not. That is what our idea is. Are you guys with me? Okay, guys, perfect. Okay, so let's plot the box plot. So what is our first formula? What is percentile? I'll put it at the bottom so you guys can see this. Now, first and the foremost, first we have to identify the 25th percentile, correct? What is the formula? Percentile, and what is the number I'll put, guys? So 265 is my 25th percentile data point. Now I need 75th percentile data point, correct? Okay, I'll just freeze this value, guys. This is changing quite abruptly for every enter. Okay, now this is 25th percentile. Now my 75th percentile value, I use the formula called percentile. I have given the array where I want to identify the percentile, and 75 is basically nothing but 0.75. So what is the number you want to do? Divide by 100. So that gives you the minimum. Now what is the minimum point we can accept? Let's do the IQR first. IQR is what, guys? 75th minus, yes. So this is you call quarter 3. This is quartile 1. Okay, 593. Now if this is the point that exists, now my maximum point I can consider is this plus 1.5 times 593, so 1740. My minimum point will be 257 minus, so this is 257 minus 593. So as per this data, I can go till minus number and 1740. So what are the outlier? Do we have any outlier in our data? Let's do that. So can I use if statement right now, guys? Application of if. Okay. So I'll just plot two things: mean outlier, and the max outlier. I'll just use that as a formula. Okay. And here any outlier. Okay. So if I want to identify any minimum value, what I'll do, if, correct, what is my minimum value check I need to do, against which, if this value is lower than my minimum value, then I want 1, else I want 0. Are you guys with me? So this basically identifies whether my data has any of the outlier point. Answer is no yet. Okay, let's look at whether my data has any maximum outlier data point. So what we'll do, if this value is greater than my max value, then 1, else 0. So as per this record, function f4, this is the freeze, and this value should be function f4 freeze. Do that. I did the freeze, otherwise every row this number will keep on changing, correct, which is not right. So what do you see, guys? Now let's see whether any outlier exists or not. Any outlier is basically, I will use what, and or. If or, I'll use the first condition, if this data point is less than minimum data point function f4, there, or this data point is greater than this data point function f4, okay, then I'll get at least 1, then 1, else 0. Fair enough. Okay, guys. So what does it suggest? That my data does not have the single negative point nor the outlier point. Now let's change that. Now because we know our outliers are very, very far-fetched, correct? I'll do one more quick check. If this value, I'll make some value is minus 5,000. Can you see that? That is, first say it is changing minimum value. Then this value I'll make minus 800. Okay. Some of the values I'll make this as 2000. These values I'll make as 2600. And one more value you change that to 1970. Okay. So now these are the values that basically screwing my regression line. Are you guys seeing on the right hand side? Yes. Correct. Now, as per the proper methodology, if we remove these data points from our graph, correct, I will show you this adjacent to each other. Let me copy paste these numbers for your purpose to show these two graphs in different way. Okay, now I'm plotting these two values. Can you see that? So the model what I built, it is following extremely high negative points. Are you guys getting it? Correct. Now yes. What shall I do? I shall remove those data points. Now in the graph, I'll remove these data points which are outliers, which are 1. Correct. So which are the data points which are outlier? This one is outlier towards maximum side. I'll delete this first. Okay. Then where is another one? I'll go and I delete this. Then I go and I delete this data point. Okay. Then I go and I delete this data point. And then I go and I delete this data point. What did you guys see? Now look at the difference between these two curves. Which one is better? I'll try to put the curves next to each other, guys. Just give me a second. This is one curve and this is another curve. Which curve is much better, guys?
This blue color is deviating too much from the dotted line.
I'll try to plot in the same curve another data point that will give you the better idea. The data points has decreased, correct? So the orange line is our original line, sorry, the new modified line, and the blue line is basically the line where you would see different trend. Now, did you guys see any changes in both the things? That is one part. And if you look at the trend line, if you try to plot a linear regression model to this, the errors on these data points will be substantially higher, correct? Whereas if you look at the orange dotted line, the errors will be lower than the black line. I'm not saying this model is really good. You might have to add another independent variables to make this line follow the curve, correct? But this is absolutely sure the error from this line, the error at 18 point will be extremely high. From this point, error is extremely high. At least on the orange line, the errors are very minimalistic. That's why the outlier treatment is utmost. So in this, we learn application of if also. Now, what will happen? You will identify through your codes, through your data points to identify this percentile points. Now you have to codify and identify whether outlier exists or not. Now that we have done using the application of if. So if you closely observe if, what it does say? If I press if and hit logic, this basically say what is my logical test. So what does logical test basically exist? What kind of a test I want to perform, correct? It can be less than, it can be more than, it can be equal to, correct? It can be something grades as well, correct? Anything, it can be anything, correct? Now if that condition is okay, if that condition has been validated, that logical test has been validated, what value do I want to assign? So if value is true, if this logical test is true, the second value will be what? It can be either 1 or it can be either 0, correct? Now if the value is false, if the logical test is false, what value shall I assign to it? If my test is failed, what value shall I assign? So this basically is a combination of these three is leveraged to make if statement looks very lucrative. And one of the powerful command you would see in Excel to create data preparation. Okay, so let's go back and look at its application, nested if, because Sanjay asked me, sir, can you cover the nested if also? I'll cover that. Okay, which is one extension of this. Let's do that. Now this is our data, correct guys? Okay, now let's suppose I want to identify the grades. Okay, now what is the grades? If somebody scores, I'll just add it here. Okay, if somebody scores above 90, then A plus. Okay, if somebody score between 75 to 90, then A. If somebody scores less than 75 to 60, then I'll say only 2 grades or 3 grades. Less than 75 is basically B grade, or I'll make it simplify for you guys. 75 to 50 is B, and anything less than 50 is F. Okay, is this clear? So now I have to apply 4 if statements to validate it. Now let's decide that. Grades. Okay, now what I'll do, rather than taking the one example, I'll simply calculate the percentage and I'll apply that. What is the graded percentage this person has got it? So what is the percentage somebody would have scored? Is this correct? Now, if this is the percentage, I'll simply round it off. Okay. So now what I have to do? If now my first condition, what I'm going to check? Logical test. Okay. If this value is greater than 90, then what I have to do? Press A1. Okay. Now, if not, then I have a lot of cases. So I'll type another if, because if it's not 90, I need to make another check. What is this value? If this value is less than correct 50, okay, or I'll make it simplified further. If this value is less than, okay, I'll make it if this L5 is less than 90, I need to put between also 75 and between. So I'll put and, okay, logical test. If this value is less than 75, no, less than 90, correct, comma, this value is greater than 75, correct, then what I want to do? Then I want to put value as A. Guys, always remember, numerical values you always have to put without quotation. The non-numerical value always have to go in within the quotations, single quotes or double quotes. Now second case, again I have to apply and, okay, if this value is less than 75 and this value is greater than 50, then I want to press what? The grade shall be B, correct. Now if else, do I need to put third condition? No, because I have another grade which is F, brackets close, brackets close, brackets close. If this A1 execute this, okay, let me check that I have completed this if statement, right? Then this is a logical test happened, then this is value true. If now this is not if, then I am executing that with the B value. Okay, I'll just make this as 75, L5 is greater than 50, then B, this is right, logically true, and F. I've done that right, logic is not right, but if value is not closing it, okay, just type another F to close the bracket, another F to close the bracket, second F to close the another bracket to F. No, that is done. This is right. If greater than 90, A plus value if true, right? If value is false, go and check if statement and L5 by 90, L5 by 70. Okay, let's make it first of all simple, and then we'll add further. Okay, if this, then I'll make it as A. If not, then B. If not, I'll make this as F. Complete. Minus signs thinks it's a formula. Oh, if this value is less than 50, okay, then make it F, okay, else make it B. If alpha is greater than, oh shit, I forgot to put the alpha here. A plus, the value is true. I'll just put A as is. If alpha is less than 5, F, I'll try to put as this. If alpha is less than 90, B, now value is B, that's right. It should close the bracket. Absolutely right. Logical test is right. If alpha is 90, whether this is executing or not, let's see that. If A and if it's this is F. Whether this is executing, right? No. So names basically we have to write in the quotes. Why it's saying this? Now this is right, correct? Not trying to type formulas. When the first character is equals, okay, or minus sign, Excel thing it's a formula. It is formula, that's right. You type equals to 1 plus 2 show 2 plus 1, okay. What the value is, my bad. I was taking single quotes. If you put it double quotes only, then it is taking as a text. Let's expand the formula. Okay. Now, if this value is basically L5 is greater than 75 and L5 is less than 50, sorry, less than 90, then what we are saying is the A grade, correct? Here we are typing A plus. Here we are typing A, else false, correct? Now, what is the issue? I have not closed the AND. Now this will work. Okay, so this guy has got perfectly A grade. So it has validated absolutely right. Now here I want to type another if. If this value is less than less than 50, then I need F, else it should be B, correct? Right, guys? Okay, perfectly worked. Got the grades, validated. Did you follow? What did I do, guys? My bad, I did not look at the quotation mark. Okay, what did we do? First, if this value is greater than 90, we are saying put A plus grade. Okay, then if we are checking in between whether this value is greater than 75 and less than 90, both the cases will be solved. One, so it will press A. If this case was not there, it would have changed whether this value is less than 50, then put fail. If not, I have directly given it's B because I have only four grades. Let's validate. Did anybody scored A plus grade in a sheet? No. Now if I change this to 91, will it work? It does. If I change this to 45, perfect. Did you see that, guys? If I put 50, it presses B. If I put 75, it puts B. If it's 70, if it's 90, it's still B. Did you see why? Did you notice this? Now, the reason is in our conditions, if you guys closely observe, so this should be 75 or equal to, and this should be less than 90, and then this should be equal to, this is perfectly fine. Then this will work. If the 90 is given, this will take B. If it is given 75, it will give you A. Did you see that? Perfect. Does it work, guys? Fine. Did you got to know the nested if and formula? Okay. So Ifs is very powerful for you to check the multiple conditions and apply the grids or apply the values for your data preparation. Okay, let's look at the next formula. What we want to cover is sum if and count if. Now sum if and count if is basically worked upon like okay, now let's look at the application of sum if. Okay, now sum if, sum you already know what sum does. It's cumulation, correct guys? Now if I put this along with f, this will do the sum only when the conditions are validated. Now what we want to do, sum if we want to give the range, correct? We want to identify the sum of the values, correct? Now I want to give the criteria. What shall be the criteria? Criteria shall be, is this value is equal to a. Okay, correct? And my sum range I want again is this. Okay, this I shall change. This is not the range I wanted to give. This is the range I shall be giving it to. So are you guys with me? My sum if range is M5 to M25. If M5 is equal to 1, sum L5 to L25. This is right. My criteria is right. M5 is equal to A. Criteria is absolutely right. Okay, I'll just make this as non-numeric. Sum range. My range is M25. Okay, that is right. I've given it properly. Sum if it should be M5. Range is that I want to give the range and select the criteria as okay. I got it. What I am doing, guys. I got it. It will work. M5 to M25, and my criteria is if it's A, then only sum. Got it? Double quotes because it's a text. So what did I do? I have given the range of all the grades. Okay, and in that range, I wanted to identify those students, those who are scored A grade. I want to identify the sum of that. Correct? So it basically suggests the sum comes out to be 865 score is basically scored by the number of students. Did you get that? What did I do? I given the range of I given the range of the criteria, and among that range I wanted to identify the criteria that satisfies it. So I have given my problem statement was identify or sum the total of the students, those who have scored more than A or A grade, correct? And the range I have given from where I need to do the same sum. Let's look at how many students have scored B grade. Okay, now I'll simply put sum if. I will give this as a range, correct? My criteria will be, guys, B, and my sum range will be the percentage of the marks. So it basically suggests the students, those who have scored B grades, are at 69 scores. Okay, now usually in practice the question will be asked to you, identify the stores where, what is the revenue if the store is platinum, what is the revenue of the stores which is gold, what is the revenue of the stores which are silver, correct? So we classify gold, premium, silver as store classification. We'll cover that, correct? Now you might want to know which of the part, how many students did score more than A grade and more than B grade, correct? Let's do that. Now if I want to identify those students who have scored, how many students have scored A grades, correct? So what I'll do, I'll simply go ahead and I'll use count if, correct? And then I can simply go ahead and give my range criteria, correct? And I will choose the students, those who meet that criteria as A. So it tells me the 11 students have scored more than A grade. And if I simply copy paste the same formula, correct, and I want to know the number of students, those who have scored B grade, I will simply go ahead and change that criteria to B. Okay. Now another way to do this same exercise is basically called cell referencing. Let's do that. Now if you guys don't know whether I need to put double quotes or single quotes, you can always refer that with the cell. Okay, now what I'll do, sum if I have given my range, correct, and I want to satisfy the criteria whatever is in the field of M27, it should pick that and it should sum the value of that percentages. Did you see what did you do? M27 as a reference. So if I change this to F, the value will dynamically change. If I go and change to B, it will change. To C, there's no value. There's A, this is the value. So rather than looking and hard coding the numbers, the best practice is to use the referencing. And so referencing basically helps you to define the criteria at the top to pick up the values. Okay, so my humble practice, guys, when you do this practice, always use cell referencing as a criteria. Okay, don't hard code the numbers. I'll just take the average if, index match, VLOOKUP I have taken, subtotal is another very good function, guys. Index match, XLOOKUP, and sum product. These are the 4 things we'll cover tomorrow. Extremely important. Average is similar to your count if statements. I just want to do the average if. What is the average of the students? I'll give the criteria same of A. My criteria will be cell referencing A, and my average range will be what is the percentage of the students, those who have got let's suppose the marks, correct? Now it will give you that if I take the average of all the students, those who scored A, the percent comes out to be 78%. Okay, let's do that. We have done average of average. Okay, is it right or not? We will validate that. Average of average is wrong because we have already taken, it's a percentage, it's not average, correct? So the value is right, it's 78. Okay, and what they have scored is 237, and if I divide this by 3, it's basically suggests the average should come out to be 79 and it's not 78.6. So that's the difference. That's why you always calculate based on the number of fields. Okay, so we'll cover these points, when to do average of average and when not to do average of average. So what did we cover in today's session? We learned outlier treatment again, if and, we have learned nested if, we have looked at sum if, count if, and average if. These all 5 are super critical functions for you to do any matches. When you want to create the dashboards in Excel, you would see the application of these tremendously. Subtotal is very powerful tool. You don't have to write sum if everywhere. If you just do subtotal, it works lightning fast. VLOOKUP we have already covered. VLOOKUP has a disadvantage. It doesn't go to the left hand side. That we will see how does index and match works. XLOOKUP is a new new formula recently Excel has added a year or 2 years back. We'll see the application of it and how it changes VLOOKUP and index with XLOOKUP. And some of the model building part. If time permits, I will teach you how to take the normality test, how to build, how to create hypothesis testing, how to build the matrix models in Excel. All of these functions will be done using some product as a function, and we'll cover all these 5 super important element of formulas. Okay, thank you so much guys, thanks for joining.